Alright, let me just start the timer so I get this. Did you start it yet?
Oh yeah, we're going.
Oh shoot. Okay, so I am Groot. Actually, I'm not Groot. You see, not Groot at all. No, I am Derek Gilhousen. You see, I've been going to Manhattan Christian School from the 4th to the, first to the 4th, the 7th to the 12th grade. And I really liked it here so far. God has wired everyone uniquely, and both me and my father are both idea men. That's just a simple fact. And as a result, my entire life, I have just wanted to be an inventor like my grandpa. Even before I met him, I wanted to do that sort of thing, and then I saw what my dad did, and I was like, what is it that he does? He's an inventor. I was like, hey, that's brilliant, I should be an inventor. So ever since then, I've wanted to be an inventor. I am also an electronics specialist with 15 years of 70% self-taught experience, the other 30% from my father. So 15 years meaning, yes, I started very young, 4 years old, I'm giving myself. Okay. So I know some C++ and some pieces of other programming language here and there, and just enough to debug, not actually enough to write my own code per se, without immense Googling, if the documentation is there. I understand the basics of assembly. I don't actually know the words used to actually program with assembly, or what they're used for, all of them, because I couldn't get just a list from my mentor. My senior project is to make something called, I have the DGAOS, okay? And it is the world's first tri-parallel operating system, or would be. Now, what was the point of DGAOS? It was to make a hyper-efficient coded operating system that wasted as little computer resources as possible. And it would be coded from assembly from the ground up, completely from the ground up with no props or anything to build it up from. And so, as you can imagine, there wasn't very many choices for mentors for that. But regardless, the point of it would be that it would neither delete nor remove your existing operating system. It would run fast and efficient on as little as 32 megabytes of RAM or a 200 megahertz processor on a 32-bit CPU. Clocked 32. I said that wrong. Ignore it. But for faster machines, if you're only using that much of the machine's power overall, today we have computers with, say, 2 gigahertz processor and 8 gigabytes of RAM, no sweat. And so, as you can imagine, that would result in very elongated battery life. And then the way the computer would work is it would boot to DGAOS, which would act as the bootloader, and at any point, if you pressed F12 on the keyboard, it would boot to the previously installed operating system, which completely removed the problem of app incompatibility. It would also utilize binomial to trinomial emulation to enable experimental trinomial-based code development, which may not be possible based on the internal structure of the actual CPU itself. Now, what stopped me from being able to do this project? First off and foremost was the lack of readily available documentation. And also, second would be that my mentor, you see, there weren't very many to choose from, and he did not speak English very well. So as a result, I was sitting there sort of trying to process what he'd told me, or what we were talking about, what he was saying. Like, did he just say CPU or GPU and stuff like that? And it would just completely slow it down, and it made it really hard to focus on the topic at hand. So we met 5 or 8 times. I can't remember the exact number of times, and I didn't write it down, the number of times we met. So it's over 5 and below 8 on approximately every 2-week schedule once I did find him. Now, over time, I noticed that things were moving way too slowly, and I think that is because he was trying to teach me, basically go through his own class with me, but I needed more of a different approach, and it wasn't working. So I went to the MSU library, which turned out had nothing on that I could find at the time. Maybe the book was checked out, I'm not sure, but they had nothing on basic, intermediate, or advanced programming in assembly. And if it was the advanced one, I could have just Googled the terms and been fine, but using a text editor with a basic compiler. So that was a huge roadblock as well, and that goes back to the lack of documentation. Now, what was the eventual solution to this? Well, when I had 2 months left, we had actually gotten pretty far in terms of what I had learned, but in terms of what we'd actually accomplished was well, not much. So I decided, okay, after looking at my progress thus far, I just decided to change my topic. So I had two options I could that I had thought of, and they're in this order that I thought of them. The first idea was like, okay, we can build it off the smallest Linux kernel that I can find, which would reduce as much overhead as possible. And that turned out to be 500,000 lines of code, and the amount of time I had, it wasn't really a good idea to try that, and I just didn't have the time to learn that much code, and on top of that, build on it. So I decided to think of another idea. So the idea I came up with was to build a fantastical box that had the following abilities. First off, it would have to be a fully functional computer. And there would be no excuse for anything less than that because your phone is a fully functional computer. Second one would be that it could jumpstart your car, because I've never seen a computer that can jumpstart your car at the same time. I mean, it's just, I've never seen it, so it's like, okay, we gotta add that feature. Plus it sounds cool. Also, another feature would be that it would be able to charge 80% in an hour or less. From your car's cigarette lighter. That means that you could be on the go, on your way to work, and plug it in, and by the time you get to work, 20 minutes later, your battery's charged enough that it'll last you the whole day. Also, another feature which I thought of, which I got super close, I'm just missing one part, and I'll show you that here soon, to doing, would be to heat water and cool water, and then also, when you take it in, you could run it through a filter, so technically you could plug it into a lake and get coffee out the other side because it would run through a Keurig packet. Which I just thought, a computer that's portable, charges your car, and makes coffee? Brilliant! I know. So I was like, hey, I gotta do this. And so another rule was that it would have to be a 48+ hour battery of constant use. And the reason for this, this is just powering the computer. And the reason for this is because in every computer I've ever seen in my entire life, the main problem with it is battery life. So why not just solve that to start off with? I mean, if you just solve that problem, fair and square, 48 hours is going to last 24 hours. So then we get earlier this year. Now, and here's another reason why this would be a good idea. Earlier this year, I created some Bluetooth headphones. I had a pair of headphones, and I was like, everybody's strutting around with their Bluetooth headphones. Well, you know what? Why don't I just add this Bluetooth capability to my favorite pair of regular old headphones? And so I did. Ended up with an 8-hour battery life, and it charged in 10 minutes. It was wonderful. Until it burned out later, but I'll get into that. So also, earlier this year, I bought and wired a 95% efficient DC to DC SEPIC charger for my laptop, or a single-ended primary inductor converter. The mechanics of that would take way too long to explain here. It worked from a car cigarette lighter without dimming my headlights, unlike when I plugged my laptop charger, which was a 60-watt laptop charger, into an inverter, which was plugged into my car's cigarette lighter. Well, that dimmed my headlights because, well, the conversion to conversion, it just was a bad idea. And so I fixed that, and now my headlights don't dim when I plug my laptop in. It's really quite nice, you know? Also, I wired up a backup wall power outlet in my nightstand with the resulting inverter left over. Now, earlier this year, another thing I made a homemade refrigerator, which utilized a Peltier unit and a couple of CPU heat sinks from old laptops that I had. I set it on a piece of styrofoam, and it actually made ice, like this much, in a day. So it did make it cold enough to make ice, and that was wonderful and brilliant. And also the top did get very hot. So I was like, hey, why not utilize both effects in my thing, you know? And so, now, the box 1.0. First off, it had AirPlay enabled, a huge battery. It charged in 1 hour. It charged in 1 hour with a 4-month battery MP3 player attached to it and a Bluetooth music streamer, which I took off my headphones. It also served as a Wi-Fi access point because that little beauty there is whatchamacallit? It's an Airport Express. And so that's how I was able to do all that stuff. I didn't have a subwoofer hooked in, but I didn't get a chance to hook that in because I didn't realize just how unsafe it was. And the whole thing, there's some connections that crossed and some circuitry started smoking. And that would be, it also had a 25-watt voltage output too. which is pretty nice. It also, yeah, it wasn't safe at all. It really wasn't previously, okay? Very bad stuff. But I learned my lesson and I increased the safety, okay, when the stuff burned out, and I replaced the majority of the burned out components with the Raspberry Pi, because a Raspberry Pi is a low budget computer that looks like this right here, okay, and it actually had some pretty good stats for the size. It's a low budget computer, so that means pretty cheap, easy on the wallet. My wallet didn't get too much lighter, it did get lighter though. I mean, I still don't even know if it's still there, but anyways. This was, I still had more features to add, but there was more room to add them too, and it was also in a nice, cute container, right? So this is the box 2.0. Now 3.0, which is, this is how the schematics of designing the 3.0 box you see here went. Okay, first off, I had to map out the power system. So first, we would have a battery with a 4.2 volt coming out to charge it from 150 watt SEPIC, meaning that you could get, well, quite a lot of amps going into this battery to charge it with. And this was just a bunch of batteries hooked in parallel, so you could charge them all pretty quick. It was 9 to 28 volts going in. If you're in between those two voltages, your thing could charge. Oh, pardon me. Anyways, also, then it would come out of there, and it would go to a 150 plus watt boost converter. That I didn't quite get hooked up in time. Because converting 4.2 to 3 volts to that, well, that's just a complication that doesn't seem to be solved. Nobody wants to do that because it really increases the amperage usage on the battery. Now, I thought since that it would be fine, but nobody's done it. So, and I didn't have time to design it in the time allotted. 2 months, you can't do that much. Also, it would have a 25 watt SEPIC converting this up to that volt. That amount of power. That be able to power everything else. Second, and this is a little more complicated, but should go a little quicker, would be how the Peltier system would be wired and the pipes would run. First off, you would have a little tiny filter on the end that would go into your lake. Then that would go up through the little filter here, and then once it goes through that, it's clean water, so the pump, which is what this is, would not get jammed. Then it would go in here, and it would have an even split off coming in between two pipes, which are half the diameter, that would end up going down, and so they would be copper pipes, one thing, with some of this stuff, which is CPU coolant stuff. It goes between the CPU itself and, it's called thermal cement. It goes between the CPU and the thing that cools the CPU. So that would go between all the cracks in this. This box would be shrunk around that, so that way it wouldn't be able to squish around the edge and start conducting across sides. This here is the Peltier unit. Peltier unit is a system that is able to create a temperature difference using a voltage difference. You can Google that and get more information on that online if you want to. And then that would just go out and, yeah, you would have hot water and cold water, long story short. And then we would have device number 2 that would hook on to the power system. You would have a 64 gigabyte SD card going into a Raspberry Pi. That provides plenty of storage for music and other stuff. If you want to play it, once this thing's complete, it'll have built-in subwoofers. Small ones, but yeah, they'll be loud. That's the hope. It'll have a 5 volt power going in from 25 watt SEPIC. Device number 3, I forget what that is. That would be the subwoofers. This is the volume. Ethernet port for connecting into Ethernet ports. Wi-Fi, Bluetooth, cell tower interface. I was thinking would go in here once I get that configured, but I did not have time to even get into that at all whatsoever. Also, that'd be wired to a USB hub, which I actually had to modify slightly, so that way the last port would be a 5 volt main power with a 1000 milliamp hour output as the phone would see it. So that way, basically, you'd be able to switch the switch and just charge your phone, or switch the switch and charge your phone, as well as power the Raspberry Pi. Because I know phone charging is a huge part, and you don't necessarily want to turn on your computer to charge your phone. I've had that issue camping for as long as I can remember. Let me tell you, it always gets me. So then there's the subwoofer setup. I didn't have time to actually build this, so I'm going to go to the next, but I thought it'd be cool to show. Idea, for the most part, basic outline. Now here comes the harder part. So I realized that in order to get the voltage out with the boost converter, I had to make a change. I decided, okay, when I want 12 volts, the 9 voltage limit on the SEPIC, well, why not just get over that by simply putting them in series, so that way your battery's minimal voltage would be 9 volts. I mean, it would cut off when the batteries are 3 volts per cell. Right, so you would have 3 batteries hooked up in series when you wanted to draw power from it, and then you'd have to hook them up in parallel to charge them. So that way the batteries would all become the same level of discharge as well as charge, which would reduce the stress on the cell. This is all theoretically speaking. So as you can see, this is just what I ended up doing was deciding to do this. Basically, I'd have a little board which I'd be able to take off, set it on the side, grab another board, and set it on top, and it would be able to switch whether it was in parallel or series by doing that. Problem with that is the little wires that I used were a little too thin, and I was really worried that if I used them, the amount of power flowing through them would cause them to, well, it would cause the solder to reflow and then touch itself, and then bad stuff would happen. I mean, we don't want any explosions tonight, so I just took the safe route and charged them up at home and wired them in series afterwards. So this introduces the box 3.0, as you can see right there. That's an old, outdated picture. This is the new picture, which is right there in front of you. The cost of this thing was actually surprising. The better, more reliable equipment, because my old soldering iron was like, the tip got corroded and wouldn't accept solder even if I scraped off the edge and dipped the tip in the stuff that flux, which cleans the tip, still wouldn't be able to pick up solder, which was quite odd. But it was like a $10 soldering iron my uncle got me for Christmas, so I got a better soldering iron and some other stuff such as heat gun so I could reuse components. That was just for the better, more reliable equipment. Turned out to be approximately $500, but after all was said and done. But then we have to go into the actual stuff that created the project itself. First off, solder. You always need solder to get stuff hooked together, because if you just twist the wires together, stuff can come loose and bad stuff can happen. Also, 25 watt SEPIC. Got that for $10. It was actually pretty cheap. As you can, yeah, anyway. Pump, and obvious reasons, you need to move the water somehow. Peltier, also for heating and cooling water. Copper pipe for transferring the heat to the liquid as it goes through. Now this was a 1 millimeter thick pipe on the inside, so you're not transferring very much water through it, and that's how it's able to transfer the heat successfully. Now Raspberry Pi, that was actually $40, which is actually cheap. Altogether, the equipment came to be $350, meaning that I could build one of these and sell it for $400 to make a profit. So it's pretty cheap, I mean, considering as far as modern day computers go, and it has some awesome features. But this is when I'm done with it. So also we have, okay, what's the future of this thing? Okay, first off, the complications of camping would be so much easier to deal with. I mean, you're out in the woods, your car battery dies, hey, no sweat, plug in the box. You're out in the woods, you need to charge your phone, you know? Your phone takes 2 hours to charge. You don't have 2 hours, you only have, well, okay, maybe you don't. Okay, so you plug it into the box, charge your phone, you know? Or if you want to go on a backpacking trip, you could charge up the box using your car in like 20 minutes, have enough power to give your phone several charges, and go out and hike up in the mountains for a few days, come back and your phone dies, so that way you're not stranded. Power outages. With a car inverter, you could plug that into this port right here with this thing set to 12 volts, and guess what? Don't matter that the power's out, you can still do stuff. You can browse the internet, you can power your router on that thing while browsing the internet with it at the same time. Via the Wi-Fi, once I get the driver set up into the Raspberry Pi. Also, boombox, emergency broadcast system, once complete. It'll, you know, yeah, reasonable, right? Coffee maker, once complete. That would be so cool. You go into college, you know, you're just like, hey, I want a sip of coffee. Press the big red button, good to go, you know? Electrical engineer's dream computer. Literally, you can test and engineer your circuits on the fly because it has a built-in breadboard, which will be on the surface, and a screen will be added, and drivers will be installed, and then it'd literally be the electrical engineer's dream computer. I mean, what more can an electrical engineer want from a computer? You know? I mean, the documentation is available for custom operating system development. Another reason why you would want this, I can develop DGAOS on this by using documentation I find online, which was the whole holdback. I didn't realize that until, like, yesterday, so. So I added it. Phone charger, car electrical system power source. You can actually power your car stereo from this thing by turning the key off and taking the key out. The electrical system to your radio shut down, but your radio is hooked in conjunction with a cigarette lighter to the same power source. So if you plug this on most cars, as far as I know, plug this into your car and plug this into the box, you can actually power your car radio off of the box. So if your car battery is dead, you have no way to charge it, like deader than the box can charge it, then, well, guess what? You're not out of luck, you know? You're in an emergency situation, you can still alert to the emergency radio, or just awesome music. Also, you don't have to worry about draining your battery dead by leaving the car on and forgetting about it. You just charge the box back. Also, water filter, an environmentally friendly coffee maker. Uses way less power than a Keurig machine. I mean, I took a Keurig machine, and I know this from personal experience. I took a Keurig machine, plugged it into my car in 250 watt car inverter, and turned it on. And I pressed the button that, you know, once it turns on, starts heating up water. I did not know that that was 1,500 watts. And let me tell you, smoke poured out. That thing was dead. And I was like, please don't kill my car. Please don't kill my car. I was running around looking for like something to cut the wires or something. Stuff was steamy in there. Let me tell you, that smell took forever to get out of my car. Luckily, the car didn't melt down. I just had to replace the inverter with the bigger inverter. So yeah, there was that. So as you can see, I mean, this thing uses like, what was it? 5 amps and it'll last 4 hours on 5 amps and 12 volts. And I know that because I plugged this in with no load. So I mean, maybe it would be 3 hours and like 3 hours and 50 minutes, but hey, who cares about 10 minutes? So you would have this here, which would be plugged into the battery itself, that's like the 5-volt output. And this would be plugged into the pump. And it actually lasted for that long, which means that it's consuming like 1 amp or so. Just a little bit over 1 amp, which is a lot better than what that other thing was consuming. I can guarantee that thing was drawing more than 1 amp from a car battery. Now, I'd like to give some thank yous to the following people. Mike for putting up with me and also for helping with the start the flow of ideas on the box, you see. I was trying to think of ideas because I knew that other idea, first idea I thought of was just a terrible idea. And he said, well, why not, you've been making all these little tiny gadgets the whole year. Why not just make that your project? And I was like, put it all together. Brilliant. So, and he was like, no. And I was like, no, yes. I'd like to thank my mom here in Gilhousen for some of the money and the even more valuable support. Also, Luke Young, Mr. Van Der Ark, and Shauna, as well as Miss Dyke and Miss Hukama, for helping me with proofreading my letters to my mentors, as well as boosting my confidence in my own formal communication skills. It helped a lot, more than you know. Mr. Kim for being my patient and highly understanding advisor. As you can imagine, going through all this stuff, I bet there was times where he was like, slow down. And there's other times where he's like, okay, come on, pick up the pace, you know? So, and he came up with some really good ideas. That whole switchboard idea, I wouldn't have thought of by myself. I'm serious. He insists I would, but I highly doubt it. I'd like to thank Andrew, which is a friend from the N Center, for putting up some very interesting and different documentation and giving me some ideas. He really connected me with some of the people who I ended up being my mentors. I'd like to thank Shauna Iser for connecting me with Dr. Rob Maher, though, and that was through her good friend of hers, as well as connecting me with Dr. Pack. Oh, I missed that. Yeah, Andrew connected me with my original mentor for DGAOS, Dr. Paxton, who then referred me to Dr. Gilhousen. And so that was really good of that. If I hadn't had them, then I wouldn't have gotten to where I am now, or the conclusion I reached. I'd like to thank the senior and robotics classes for helping me come up with features to add to the box. I literally came to school, I was like, all right guys, what should I add? This is what I wanted to do, what else should I add? What would be cool to have on my computer? And they just threw out ideas. It was quite brilliant. I'd like to thank my mentors, Dr. Gilhousen, for helping me with DGAOS as far as he could, and Dr. Rob Mayer for helping me on the box. That concludes my presentation here. Now I would like to show an active demonstration of this. First off, let's make sure that it can actually charge your computer. And yes, it can. It can charge your computer. I tested it before we even talked. So you plug this into here. That's plugged in. You make sure this big red button is pressed down. Should I press the big red button? Yeah. Yeah? Do it. All right. We'll press the big red button. So we plug it into here. The green light goes on, and this little light starts blinking. And that means it's charging. If I open up this computer, you can see. No, it will not stop smoking. Do not cheat. 23% and plugged in and charging. That's so it's working. Let's unplug that before it drains my battery on here because I did not charge it all the way full. I only charged it 3%. Enough to get through the presentation. Now let's. Oh, actually, I need to plug that in. Let's plug. That's a good point. One thing after another, guys. Let's get this thing so we can test out the Raspberry Pi. So first off, to test out the Raspberry Pi, hey, could you hold this like right here? Just don't let it move too much.
Here. Explain Raspberry Pi.
I did.
Did you?
Yes. You can ask questions soon. So first off, we plug this guy into here. Yes, it will have its own built-in display when I'm done with it, but I didn't have time, okay? All right, come on, plug in. And then, once that's plugged in, we flip this little switch here. No, other way, yep. And now, that will happen. And then, okay, I'll trust you. Alright, then it will start booting up, and the first thing you see is a big shift key, telling you to shift it for safe mode. See, there's the message it sends you to make sure that it's booting right. If there's an error, it'll tell you right here. It'll probably go into command prompt and fix it. Long story short, here is the desktop. I will need a keyboard. Oh yeah, and that, could you actually? Okay. So let's plug that into here. A keyboard would be excruciatingly nice. Come on, don't miss the hole.
Can you search the internet on this?
Yes. As soon as it's plugged in. I don't have the drivers for the Wi-Fi card installed yet. I couldn't find them, but once I do, it'll be able to strip the net without this big long cord connected to it. So old-fashioned, I know. So as you can see, we've got a mouse, and it moves around. Now let's, while we're waiting for Mr. Kim, we can look at stuff. First off, we've got some programming tools, so we can program right here, right now, without even an internet. Second, we've got some office tools, so we can start writing documents, Word document, all that stuff. We've got the internet. Now, if we go to the Epiphany web browser and open that up and plug this keyboard in, right here. Come on, you can do it. I believe in you. Yes, it did it. We're happy. So it should type. Yep, it typed. Okay, good. We're worried I'd have to find drivers for that. So let's go and www. My good old friend Google. No access to.
Goose.
Go. Dot. Because DuckDuckGo is pretty awesome. command is what I tend to use, so let's be realistic. Let's let that load. It's slightly slower loading than Google, but that's just because they're from slower servers and they're not used to the server load. Oh, that's from the hole there. Okay. You know what? Let's actually. Oh. It's loading. You can see it loading. It's got messages to show you. Oh, it also shows the CPU usage there right out of the box, which is really quite nice. So, if we look here, we've got a terminal, a task manager, text editor, calculator, all that stuff is really neat in this basic computer. And if we go to games, we've got Minecraft installed. Oh. So we can load that up right away, and it's quite fast. You can start a game, create a new world, build the terrain. It's a little bit laggy on the mouse, but it's pretty awesome that it has Minecraft installed. I mean, it's because it uses an ARM processor that it has Minecraft installed in the first place. So let's just make sure everything's working. By the time we get done with this, DuckDuckGo better be loaded, or else I'm going away from you. Google. So as you can see, you can move, you can walk forward, back, and left and right, and play stuff, like for example, this block here, make something, Legos in Minecraft, yep, it's awesome. I believe it. Anyways, we're done with that, enough gameplay. Let's go to quick title and close this window. Now, DuckDuckGo is taking too long. I think that it's just not compatible with the Switch. And it could just be that there's a bug in the web browser. Or who knows what it is, really. I don't have much time to work on this. Anyway, let's go to Google. Google's compatible with everything, which I'm told.
Your HTTPS.
Yeah, www. Google's always HTTPS. Let's try HTTP. Really, I just want to test this thing out, you know? Search the web. Why not? Come on, go. Maybe the web browser is a little bit buggy. Yeah, it is a little buggy. I'm probably going to switch operating systems now, which is quite easy. Just putting in a custom web browser. But long story short, the computer works and loads stuff. So unplug the internet and turn this thing off. Boom. And unplug it. And let's go to my car and test out the stereo. I might need 3 hands here. If I had 3 hands, I just want to.
What do you need me to do?
I want you to hold this.
All right.
Thank you.
Just say
I
the
just
word.
really want to grow a 3rd hand. I have no idea. It'd be so easy. I mean, I should really start a petition with that with the guy that's going to. All right. So let's go ahead and go out some cars. We'll have to bring this and set the voltage lower. We don't want to burn out the car because we can at 18 volts. I mean, designed to run on 12 volts, not 18. Don't want to take any chances with that. So first things first, to change the voltage, plug that in there. And yes, there will be a built-in voltmeter when I'm done with it. But the voltmeter that I got is very buggy and just is not reliable and is always wrong. So I'm not going with it. First off, let's turn this guy on. Okay, and then we just take a small screwdriver. I had one. I know I did. It was around here somewhere. I feel like Dora the Explorer now. Can you see the screwdriver? So let's turn that down. Oh, wrong direction. I turned it up. That's a bad idea. I stood on the wrong side of the block. There we go. I felt it that time. So we'll turn this down. 15 volts. Kind of 14 volts. Let's get it down to 12.5, 12.3, 11.96. No, my car likes. 12.5 is good. 12.3. That's close enough. We'll just leave it at that. Okay, guys? Alright. So we've got that set up. Now, when I'm done with this, everything will be ironed down so you can bounce the box around, drop it, you know, usual stuff. But right now we can't do that. You can't even let it.
Derek, before we go outside, let's open it up to questions.
Alright,
It's
alright.
easier to do that.
Let's do questions. First question. Did I just blow you away that much? Okay, here we
How
go.
long to make a cup of coffee?
haven't actually made a cup of coffee yet. You see, I'm just missing some essential pieces that go between this and that.
Theoretically.
It's all theoretical,
Yeah.
and I know my dad said if it hasn't been tested, it doesn't work, but I assure you that I really hope it will work.
So, what's your computer called again?
It's called a Raspberry Pi.
Raspberry
You can pick them
Pi.
up at Radio Shack.
Did you have to download and program that stuff with?
Actually, I did have to download it and then drag and drop onto the USB stick. I mean the SD card. So that was the easy part. The hard part is getting all the drivers for all the stuff I'm adding to it.
Did it come with all the apps and stuff?
Nope, didn't come with anything. I actually had to go onto the Raspberry Pi website and do some Googling and ask a friend of mine for some help on getting started with this because he's actually done this before. And then I found out you just go on the website and it's right there. So yeah, I just went on the website, downloaded a zip file, unzipped it, used ditto, the command on Mac to copy it over completely exactly as unzipped, which it was recommended by someone, so I did it. Ditto is a command line tool. Yes?
This isn't really a question, so I'm tossed out for this, but something I've noticed over the last few years about you is that you have something that you're passionate about. And just want you to know that many people go through their whole life without having something like that. So it's I'll be interested to see where you go with it. It's pretty cool.
And I will be finishing DGAOS as soon as I get the resources and go through school and learn how that is. I will be, so look for it for a store near you. Or a website near you. I don't know. What else? Anything else? All right, you.
What's the DG, the name stand for?
DGAOS stands for a DG-approved operating system.
Derek Gilhousen.
Or a Derek Gilhousen approved operating system. DABOX stands for Derek Approved Box. Because, you know, I want to stay with the 5-letter acronyms, you know. I mean, PCMIA, do you even know what that stands for?
No.
People can't memorize something acronyms.
Computer industry acronym.
Yeah, he knows it.
One of the things that I noticed that was missing in the presentation was, but wait, there's more.
Why didn't I think of that? Mr. King, you're fired. That's okay. No, stay here. It's okay, it's okay. All right, so.
So Derek, when you're not walking these halls, what are you going to do? What's next?
Well, I've been thinking about how I really wish I had picked the judges. So thank you.
I mean, once you leave the school.
All right. Once I leave the school, I plan on going to NSU for 2 years.
Okay.
And then switching to a higher up school, depending on if I think it offers higher opportunities or not. But you see, the end of my years at here weren't exactly golden, so I just want to prove myself in college, show my actual potential.
Okay.
So yeah, and if you don't believe me about this thing getting hot and cold on one side, I'll plug her in and it'll work once. You can tell the temperature. The problem is that these aren't actually touching it well enough to actually wick the heat away. So. And also there's no bridge between them pulling them together, so it only works once before it starts having weird issues that arise when both sides get hot. Any other questions? Are we all good, or should we go like test this thing out? Because I'm looking to go test this thing out. That's just my personal opinion. All in agreement, say aye.
Aye.
All right. Let's go plug this thing into my car.